नमस्ते दोस्तों। लास्ट लेक्चर में हमने देखा है कि बेसिक्स ऑफ फोरियर सीरीज़ क्या होता है, ट्रिग्नोमेट्रिक फोरियर सीरीज़ क्या होता है, डिरिचलेट कंडीशंस क्या होते हैं। तो आज हम फोरियर सीरीज़ के प्रॉब्लम्स देखने वाले हैं। सो जस्ट क्विकली आई विल रिव्यू द बेसिक्स ऑफ फोरियर सीरीज़। The objective of the Fourier series is to understand and resolve the signals in the frequency domain using Fourier series and the Fourier transform। जो भी सिग्नल टाइम डोमेन में होता है वो सिग्नल हम फ्रीक्वेंसी डोमेन में रिजॉल्व करने वाले हैं, और वो उनका फ्रीक्वेंसी इंफॉर्मेशन क्या है, उनका फेज स्पेक्ट्रम कैसे होता है, एम्पलीट्यूड स्पेक्ट्रम कैसे होता है, वो हम देखने वाले हैं, सो दैट यू कैन डिस्टिंग्विश सिग्नल इन द फ्रीक्वेंसी डोमेन। तो एंड एनालाइज द सिस्टम इन द फ्रीक्वेंसी डोमेन। जैसे टाइम डोमेन में हम एनालाइज करते हैं उसी तरह हम फ्रीक्वेंसी डोमेन में भी एनालाइज करते हैं। ओके, सो सबसे इम्पोर्टेंट पार्ट ट्रांसफॉर्म में होता है कि बेसिस फंक्शन हमने देखा है। तो बेसिकली सो एवरी कंटिन्यूअस फंक्शन इन द फंक्शन स्पेस कैन बी रिप्रेजेंटेड एज अ linear combination of the basis functions, at linear combination of the basis function, just as the every vector in the vector space can be represented as a linear combination of basis vectors। मतलब जो सिग्नल होता है टाइम डोमेन में, that signal can be represented with the linear combination of basis functions। Any signal in the world which may be the periodic or the aperiodic can be represented using linear combination। उसी तरह फोरियर ट्रांसफॉर्म में अगर देखेंगे so e raised to j omega t is a basis function होता है। अकॉर्डिंग टू इल्यूर्स आइडेंटिटी अगर आप देखेंगे सो दिस इज इक्वल टू कॉस ओमेगा टी प्लस जे साइन ओमेगा टी। इसका मतलब ऐसा होता है, सो कॉस और साइन आर द बेसिस फंक्शंस। यूजिंग साइन एंड कॉस यू कैन रिप्रेजेंट एनी पीरियोडिक सिग्नल एंड दैट इज कॉल्ड एज योर द बेसिस फंक्शन। अगर लैप्लास में अगर देखेंगे सो ई रेज टू एस टी is the basis function in the Laplace transform, and if you go for the Z transform or if you go to any transform, there is a one basis function will be there। So using that basis function, so you can represent any signal which may be the periodic or the periodic with the linear combination of so this basis function, उसको बोलते हैं। अभी Fourier series में basis function is e raised to j omega t, that is the sine and the cos। Sine and cos are the basis function। Using sine and cos you can reconstruct any periodic signal with the help of this sine and cos, उसको basis function बोलते हैं। So this is the waveform, you know, the sine of 0 is a 0 and cos of 0 it is a 1। So accordingly there is a 90-degree phase shift, so you should know the values of what is the sine 0 is 0, the sine 0 is 0, then the sine pi is 0, sine 2 pi is 0, sine 3 pi is 0, 4 pi is 0, sine pi by 2 is 1, sine 3 pi by 2 is minus 1। So you should know the values of the sine and the cos, how it varies with respect to the angle in the degree or the radian, because that we are going to use to solve the problem of the Fourier series। Next, quickly this also you remember, so degree and the radian, how to convert degree and radian to the degree you can see, but here you should know the values of the sine, what is the sine 0, then what is the sine for example the pi by 4, what is sine pi by 2, or what is the cos pi by 2, because these values are required to solve the problem of the Fourier series। So unless until you know the values of the sine and cos, it is difficult to solve the problem। So therefore you remember this table, and if you just do the practice for 2-3 times, you can easily recall the values of the sine and cos for the any values, because by using this sine and the cos, for example sine 0 is 0 or sine 90 is 1 or the sine 360 is 1 or the 2 pi is 1, so we can reduce the complexity of the problem which we are using in the Fourier series। Okay, next, already I have taken one lecture on the Fourier series। So basically Fourier series is an accurate representation of a periodic signal x of t and consists of the sum of sinusoids at the fundamental and harmonic frequencies। So कोई भी signal x of t जो होता है, so this is a signal x of t which is represented in the time domain, so that can be reconstructed with the help of linear combination of sinusoidal signal of the fundamental and the harmonic frequencies। और उसके एक्सप्रेशन भी हमने देखा है, मतलब using sine and cos we are going to reconstruct any signal So that we want to solve the problem, and we want to demonstrate how any signal can be accurately represented using the sine and the cos components. Okay, this is just quickly I will review. There are two kind of the Fourier series we are using. One is called as the trigonometric Fourier series, और दूसरा बोलते हैं कि exponential Fourier series. First, we will look at the trigonometric Fourier series. So this is the important equation for this is a trigonometric Fourier series. Okay, so this trigonometric Fourier series is given by x of t is equal to a0 plus summation n is equal to 1 to infinity an cos n omega 0 t plus n is equal to 1 to infinity bn sin n omega 0 t. और इसमें जो है so this an a0 an and the bn, these are called as the trigonometric Fourier series coefficient. तो हमें first trigonometric Fourier series coefficient compute करना पड़ता है. Trigonometric Fourier series compute करने के बाद we have to substitute the values of a0, we have to substitute the values of an, we have to substitute the values of the bn into this equation, and this particular equation is called as the trigonometric Fourier series. So this is important slide, and आपको अगर कोई भी problem solve करना है तो these four equations, one then this is the second equation, this is third equation, and this is fourth equation आपको recall करना है. So if you can able to recall, and it is very easy to recall, if you look at the a0, generally this a0 is called as the DC value of the signal, okay, or the average value of the signal, and this is given by a0 is equal to 1 upon t, where the capital T is called as the period of the signal, and integration for one complete the period x of t into dt, it will give average values. The second an is equal to 2 by capital T, integration for one complete period x of t into cos n omega 0 t into dt. So this an is associated with the cos term, and this cos is also called as the even function of the time. So generally this an is called as the even Fourier series coefficient, and bn is called as the odd Fourier series coefficient. The difference in the an and the bn is only between the cos and the sine. So just you remember a0 is the DC value, and the an is called as the even Fourier series coefficient, and bn is called as the odd Fourier series coefficient. Only difference in an and bn is over the cos for the an, and for bn you have to use the sine, and यहाँ पे 2 by t is a common, और यहाँ पे a0 के लिए 1 by t है, and all for 3 Fourier series coefficient the integration is for one complete period. So just you remember, this is an important slide to solve any problem on the Fourier series. Just you remember this x of t formula, and formula for the a0, formula for the an, formula for the bn. With the help of these four equations, we can able to solve any problem on the trigonometric Fourier series coefficient, और उसमें हम देखेंगे how any signal can be represented using sine and the cos, and that also I am going to demonstrate you with the help of the MATLAB software. Okay, next Dirichlet conditions हमने देखे हैं. So already there is a separate video is available. You can go and you can look at the Dirichlet conditions. For existence of the Fourier series, the signal x of t should satisfy the Dirichlet condition. If it does not satisfy the Dirichlet conditions, Fourier series exists होता नहीं है. So I will not go in the detail in the Dirichlet conditions. So you can look at that separate video. But you have to write when you are solving the signal x of t satisfies the Dirichlet condition, so the Fourier series exists. So that is the sentence is important. Then you can proceed for that trigonometric Fourier series equation and the trigonometric Fourier series coefficients, and accordingly we can solve. Now we will look at the properties of the Fourier series, which is very important, and always every time I tell you that properties make your problem very easy. तो आपको first property अगर आपको समझ में आ गया तो आपका complexity of the problem is reduced by 75%. तो आपको ज़्यादा कैलकुलेट कंपटीशन करने की कोई भी ज़रूरत नहीं. तो इसलिए जस्ट प्लीज़ यू गिव द काइंड अटेंशन टुवर्ड्स दिस वेरी इंपॉर्टेंट स्लाइड, दैट इज़ द सिमेट्री प्रॉपर्टीज. इफ द फंक्शन मतलब होता है कि तुम्हारा दिस द एक्स ऑफ टी इज अ सिग्नल, सो दिस कैन आल्सो बी कॉल्ड एज द फंक्शन. सो इवन सिमेट्री means if the signal x of t is a even, only cosine and the associated coefficient exist. Fourier series में 3 Fourier series coefficients are important. One is called as the a0, which is called as the DC value of the signal. Another Fourier series coefficient is called as the an, and this an is called as the even coefficient. It is called as the even coefficient of the Fourier series, and another is called as the bn, which is called as the odd coefficient. तो हमें Fourier series computation करने के लिए we have to compute a0, an and the bn. So this a0, bn and the an and the bn, it will take time to compute, but for every signal a0, an and the bn does not exist. So हर सिग्नल में a0, an, bn कैलकुलेट करने की ज़रूरत नहीं. अगर आपको ये सिग्नल का प्रॉपर्टी समझ में आ गया, whether the signal x of t is a even or whether it is a odd, so you can reduce the complexity of the problem, and some of the Fourier series coefficients are directly 0. So you can write, so an is 0 or the bn is 0, so that directly the problem complexity is reduced tremendously. So let us look at the symmetry properties. First is a even symmetry. If the signal x of t is a even, if the signal x of t is even, only the cosine matlab I told you, the cosine is related to the an term and the sine is related to the bn. So an is called as the cosine coefficient and bn is called as the sine coefficient. So even symmetry, if the signal is even, only the cosine and the associated coefficient exist. It means that the a0 and an term exist, and the bn term will be automatically, the 0 will be there. There is no there is no need to compute the values of the bn. So your 50% complexity is reduced here. So if the signal is even, a0 and the an are present and the bn will be 0. The next, if the signal is odd, only the sine means the bn term. So only here the a0 and the bn term will be present, and the an term will equal to be 0. There is no need to calculate the values of the an. Once again remember, if the signal is even, a0 and the an term present and the bn will be zeros. If the signal is odd, the a0 and the bn are present and the an is equal to 0. For even, term is associated with the an, therefore an is present. For the odd term, bn is associated, therefore the a0 and the bn are present, and here an will be zeros and the bn will be zeros. That easily you can remember. From the even means an is present, odd means the bn is present. A0 will be there everywhere, but from the symmetry properties of the a0, that also you can calculate whether the a0 is 0 or the some other values will be there. If the signal is neither even neither odd, that it contains both the component even and the odd, so all the term coefficient exists, that is the a0, an and the bn. So this particular slide help you to reduce the complexity of the problem by the 50%. So directly आप लिख सकते हैं, the signal is even, therefore bn is equal to 0. Signal is odd, so an is equal to zeros. So otherwise, if the signal is even and odd, so you need to calculate all the coefficients. So these are called as the symmetry properties of the Fourier series. So another, also there is again very important tricks I am going to give you, that based on some other properties you can also get lot of information about the Fourier series. Matlab, I will tell you that within these two slides you will get 75% of the answer without doing any calculations. Matlab, you can guess more than 75% of the answer. मतलब आपको answer calculate करने के लिए बहुत ही easy हो जाएगा. That we have seen, whether the signal is even, the only a0 and the an term exist. If the signal is odd, a0 and the bn exist. And next property is that the half wave symmetry. Half wave symmetry का मतलब होता है, if x of t is equal to minus x of t minus t0 by 2. So this particular the property is called as the half wave symmetry. मतलब this signal is delayed by the t0 by t. t0 is the total period of the signal. Agar this t0 is shifted by the half period, so then the x of t will look like as a minus x of t minus t0 by 2. So this is a signal which is shown as the triangular waveform. So once again I will show you this particular triangular waveform. Here if you look, or I will take another signal, for example this is a square waveform. Okay, so this is square waveform. Here I will write, it is the minus 1, 0, it is 1, then it is 3, it is 5, it is 1, it is minus 1. So this is a x of t. Now whether to check whether this signal is the half wave symmetry or not. So according to this equation, so I have to calculate x of t minus t0 by 2. So t0 matlab hai period of the signal. So one complete positive and the negative half cycle is called as the t0, and this t0 is equal to its period is a force. And t0 by 2 matlab t0 by 2 is equal to t0 is 4, it is equal to 2. Now what I will do, I will shift this signal by the t0 by 2, that I will write x of t minus t0 by 2. Okay, matlab this is equal to x of t minus 2. The signal is delayed by 2 unit of the time. When the signal is delayed by the 2 unit of the time, so this is t and this is x of t minus t0 by 2. So if you look here, the 0, okay, then if the signal is shifted by the 2 unit of the time, मतलब ये जो तुम्हारा -1 रहेगा, so this -1 it is a delayed means this it is equivalent to shift the signal in the right direction by 2 unit of the time. मतलब when I will now I am going to shift this signal by the 2 unit of the time, यहाँ पे 0 पे यहाँ पे आता है, so 2 unit मतलब I have to this shift by the 2 unit of the time. Now this is the signal which is x of t minus t0 by 2. So this signal is shifted by 2 unit of time in the right direction. And if you look at this x of t and x of t minus t0 by 2, so it is exactly, that is a inverted signal in the amplitude domain. If you see its amplitude is 1, here amplitude is a -1. यहाँ पे अगर 1 है, -1 है, तो amplitude is 1 है. मतलब it is amplitude scaling by the -1. मतलब so x of t is equal to, so this is x of t and this is x of t minus t0 by t. It is just like the inverted in the time domain, inverted in the amplitude domain, like the amplitude scaling. तो मतलब इसका amplitude negative है, means x of t is equal to minus x of t minus t0 by 2. Such type of the property is called as the half wave symmetry. अगर signal half wave symmetry है, only you remember this is very important, the property, if the signal is half wave symmetry, only odd harmonics are present in the Fourier series. Odd harmonics means it is equal to value of n is equal to 1, value of n is equal to 3, value of n is equal to 5, n is equal to 7 and so on. There is no need to calculate the n is equal to 2, 4 and etc. So therefore odd harmonics are important. You remember if the signal is half wave symmetry, only odd harmonics exist. So accordingly you can reduce the complexity of the signal. So next thing is whether the signal is a continuous or the signal is discontinuous. From that also you can predict that whether the coefficients are proportional to 1 by n or whether the coefficients are proportional to 1 by n square. The first, let us look at what do you mean by the continuous or the discontinuous signal. The discontinuous signal is that signal which abruptly changes its value from 1 to 0 and from 0 to 1, again 1 to 0, 0 to 1. So this is a discontinuous. So if the signal is discontinuous, the coefficient, whatever it is, even or the odd signal, a0, an and the bn, so the coefficients are proportional to 1 by n. So just it's very simple, just you look, the coefficients are proportional to 1 by n. And if the signal is continuous means it is not going from the 1 to 0 or 0 to 1, just it is going, that is slowly it is rising and slowly it is the declining. So based on whether slowly it is going up or slowly going down, so such kind of the signal is a continuous signal. If the signal is a continuous, the coefficients trigonometric are proportional to 1 by n square. 1 by n square. It means we have got lot of information based on the discontinuous or the continuous. You can guess whether the coefficients are proportional to 1 by n or whether the coefficients are proportional to 1 by n square. Then if the signal is half wave symmetry, only odd harmonics are present. If the signal is even, only the a0 and the associated an coefficient present. If the signal is odd, a0 and the bn present, so other term will become zeros. So you got here the around 75% of the information about the Fourier series. Now let us look. So this is the triangular signal. The first thing, you just check whether the signal is even and odd. So just by looking at the signal is said to be even when the x of t is equal to x of minus t. So if you just fold the signal to the vertical axis, so you can plot x of minus t. So already that you know how to check whether the signal is even or odd. So this is your the x of minus t, this is x of minus t. So if you see x of t, if I call this as x of t, this is x of minus t, both the signals are same. If both the signal are same, then the signal is even. If the signal is even, already I told you, only the a0 and the an coefficient exist and the bn is equal to 0. So here you got the 50% of the answer. The next thing, about the DC value. The DC value is that value which the coefficient is represented by the using a0, that is a trigonometric Fourier series coefficient a0 is called the DC value. So how to predict the values of the a0 is that in a given signal, if there is a equal positive half cycle and equal negative half cycle, equal positive and the equal negative. So just if you look at the signal, so this is the positive half cycle. So this is a positive half cycle, and if you see, okay, so this is negative half cycle. So there is equal positive and the equal negative half cycle. In that case, the coefficient a0 is equal to 0. So here we have guessed a0, an. We have guessed a0 is equal to 0 because equal positive and the negative half cycles are there. Then second thing is about the half wave symmetry. So to guess the half wave symmetry, just you have to plot that x of the t minus t0 by 2. So if this x of t minus t0 by 2 is equal to minus this, so if you plot this x of t minus t0 by 2, so it is exactly the opposite of this signal in the amplitude domain, then it means that the signal is of the half wave symmetry. If the signal is half wave symmetry, only odd harmonics present, only odd harmonics are present. So we got this information, odd harmonics and this, and about the discontinuous or the continuous. So if you look the discontinuous and the continuous, the signal is going slowly and it is going up, again slowly coming down, means such type of the signal are called as the continuous signal. If the signal is continuous, the coefficients are proportional to 1 by n square. So here you got all the 75% of the prediction about Fourier series coefficient of the signal. So the symmetry properties will help you to predict about the coefficients. So directly you can write here bn is equal to 0, you can write a0 is equal to 0, that only you need to compute only the an. Again in the an, it is because half wave symmetry only odd harmonics exist. Again you got some information about the an. And another thing, it is a discontinuous signal, so the coefficients are proportional to 1 by n square. So you got around 75% of the information. Now we will solve the problem and we will check that whether these symmetry properties, what I told you, whether that fulfill the requirement of that problem or not.